find the volume of this solid obtained by rotating about the line x equals -1, the region bounded by the curves y equals 2x squared minus x cubed and y equals 0. So let's graph this these two curves. So y-axis, and here's the x-axis. X-axis is same as y equals 0. Okay, now graphing 2x squared minus x cubed is not that easy, so I wanna use graphing calculator. Okay, so this is the graphing calculator. So 2x squared minus x cubed, and graph and zoom in to see. So the shape will be, it's the negative cubic function going decreasing and like this. Okay, so the graph looks like it's coming down and going like this. Here is 1, here is 2 from the calculator. Okay, from the calculator, this is the graph, and this is 2, this is 1, 0. Okay, this is the graph, and y equals 0 is the x-axis. So the region bounded by these two curves is this. Okay, and we want to rotate this region about the line x equals -1. So let's draw x equals -1. So here's -1. So we don't need this part of the graph. So I wanna erase that one. So x equals -1. And we are using cylindrical shells. Okay, in fact the disc washer method is very difficult. So shell method. Okay, we are revolving about x equals -1. So we need to take a sample rectangle parallel to this line, so it will be a vertical line. So we want to take a sample rectangle parallel to the axis of rotation, and this of small width here on x-axis, delta x. Okay, small width. This delta x suggests the volume formula will be in terms of dx, and this sample rectangle could be taken anywhere in between 0 and 2. Okay, anywhere starting here all the way to 2. So the limits 0 to 2, and when we revolve this about this line x equals -1, we'll have the surface, we'll get the surface, just the outside part of a cylinder shell. We'll get a shell, and we need to find the area of that shell, the surface area of cylinder. Let's rotate this small rectangle about this line. So let me erase this part because I don't need. Then I'll have, this is the top part, and this is the bottom part. Okay, let me draw over here. So I have a skin of cylinder just outside shell. I get a shell here, and the axis of rotation, that is, this is x equals -1, and x-axis is here. Okay, that's y equals 0 or x-axis. Now to find the surface area of this cylinder in terms of x, the formula is 2 pi r h. R is the radius of the cylinder, h is the height. Okay, so the radius is from here to, this is the sample rectangle we are taking here, and this is the sample rectangle. So let me use, here is, this is the part, and this is the generic point on the curve. So the generic point is x comma y, and y is given by the function y is 2x squared minus x cubed. Okay, from origin to that sample rectangle, x horizontal direction and y the vertical direction. So this point is, we just figured out, x comma 2x squared minus x cubed. Okay, so here to here, and our x-axis is here in fact. and here's the origin. So the distance between these two lines, okay, these are two vertical lines, so the distance is always same, that's 1. So this is x equals -1 and x equals 0. Y-axis is same as x equals 0, so this distance is 1. We are trying to find the radius, that this distance from origin to get to this point. We know this is x, this is x, and this is y. Y is given by 2x squared minus y x cubed, so this is x, and here to here this is always fixed 1. So this is 1, and here x, so the total, the radius, so the radius is 1 plus x. Okay, so the surface area 2 pi r 1 plus x. The height is y, okay, no matter where we take, and this is just 2x squared minus x cubed. Okay, now done. Once we find a, we just plug this a into this formula, okay, the volume formula, and find the definite integral. We can simplify before we get to the volume formula. Let's simplify. So multiply these two binomials, 2 pi 1 2x squared 1 minus x cubed, x 2x squared plus 2x cubed minus x cubed x to the 4th. That's 2 pi. Can we combine 2x squared? No, just 2x squared minus x cubed and plus 2x cubed, just plus x cubed minus x to the 4th. Okay, this is the surface area, in fact the surface area of shell. Now the volume is given by, what is the formula? 0 to 2, because our sample rectangle could be taken anywhere in between 0 to 2. So 0 to 2, and this area is 2 pi times this polynomial, so 2 pi can be pulled outside, constant 2 pi outside, so 2x squared plus x cubed minus x for dx. Now let's evaluate this 2 pi. I want to find the antiderivative of 2x squared. 2 is 2. For x squared, x 3 over 3. For x 3, x 4 over 4 minus x 4, x 5 over 5. And we want to go from 0 to 2. Okay, so 2 pi. I want to evaluate this function at the upper limit 2 minus evaluate this lower limit. So upper limit minus lower limit. Plug in 0, everything 0. So lower limit is easy. Plug in upper limit 2. 2 cubed 8. 8 times 2, 16 thirds. Okay, 16 thirds plus 2 raised to 4. 2, 16 over 4, just 4, minus 2 to the 5th, 32 over 5. Okay, let's simplify. That many cubic units is the answer. So 2 pi. Now 3, here is nothing, means 1, and 5, the common denominator is 3 times 1 times 5, 15. 3 goes 15, 5, so we have to multiply 5 times 16, 80. To get 15, we have to multiply 15 times 4, 60. To make 15, multiply by 3 times 6, 96. Okay, let's simplify. 2 pi 80 plus 60, 140 minus 96. So this 3, 1, 4. Okay, 4, 13, 4, 44. So 44 over 15. Okay, so the final answer is 42, 88 15th pi, 88 15th pi cubic units.